Welcome everyone, both the folks that are here with us in the Zoom, as well as folks that may be watching via YouTube. We're about to get started with the computer vision office hours and discussion. I am excited to have with me Sidha and Reza Zadeh. I will let them introduce themselves. These office hour sessions here at TWiML Fest are super informal. We will, take as many questions as we get from the audience. I'll be guiding some discussion as well. We'll be talking amongst ourselves. And we'll be doing that for the next, hour or so, depending on the conversation and the questions we get. Let's start out by having my colleagues here on the panel introduce themselves. Sidha?
All right. Hey everyone, I'm Sidha, and currently I'm a self-driving car architect at NVIDIA, where I get to work a lot on training neural networks and really learning about all the interesting edge cases that we need to consider while deploying cars out on the roads. And I also am a machine learning lead at the Frontier Development Lab, which is an AI accelerator for NASA and the European Space Agency. So it's a lot of cool, different data sets than what we're used to on when compared to the automotive side of things. So it's a really nice place to learn how to deploy at a TRL level 9 and really get things up and going in the satellite data. That's all from my side, and I'm really excited to be here.
Awesome. Reza?
Hey everyone, I'm Reza Zadeh. I'm CEO of Matroid. We are bringing computer vision to the masses, in particular, three big industries that we're focused on: manufacturing, industrial IoT, and security. These three industries are able to use computer vision very productively, and our product lets them do that. And I'm also an adjunct professor at Stanford, where I teach distributed machine learning as well as graph theory to the graduate students who are interested in those topics. Thank you for having me, Sam.
Awesome. Both of you are former podcast guests. Sidha, I think at least twice. You did a trends. We did a computer vision. I think it was computer vision trends a couple of years ago. And Reza, it's been quite a while. I'd love to hear maybe an update on Matroid. You started and you mentioned some industries that you've been focusing on, and that sounds different from what I remembered from a couple of years ago. I think of, or I thought of the company as focused on providing, what I might characterize as like brand surveillance on video streams. At least that's the demo that I remember. So give us an update on what you're doing and how you're applying computer vision in that area.
Sure thing. So our product's sufficiently broad that it can handle a lot of different use cases. So what we have is a point and click product that lets you monitor video streams in real time, as well as go back in time and search large collections of video. So like if you have an S3 bucket filled with video and you'd like to search for whatever it is that you would like, you're able to do that in a point and click manner with Matroid. So the use cases of looking for a logo on real-time video, it's still there. However, as a company and as an engineer, I'm just more excited about really industrial use cases where I'm seeing computers become the ultimate sensor, the computer vision become the ultimate sensor. So really exciting use cases that are growing much faster than logos and brands is looking for damage and cracks and other defects on big industrial pieces of equipment like bridges or wind turbines. This has been something that is really taking off. Anyone who has an expensive piece of equipment would like to make sure that their equipment is not damaged and is weathering the elements well. For example, wind turbines get hit by lightning strikes, they get hit by birds. And get hit by all kinds of other things. So they have to be constantly monitored, and they are monitored by video. And some poor engineer has to be looking at that video. And of course, that should be automated. More generally in manufacturing, every manufacturer makes stuff, right? They all make stuff. And that stuff has to be checked for quality. And if that thing can be checked for quality visually, then you can put a camera at the end of your manufacturing line and monitor that. And the same product that we built back in 4 years ago for building a detector, which is basically a neural network that can be tuned to look for whatever you want, building detectors and deploying them on live video streams, as well as deploying them on potentially petabytes of video, that same product applies. And so we haven't pivoted as a company. The product's exact same product. We're just seeing way more uptick in these other industries, manufacturing and industrial IoT, which is super exciting right now, because as an engineer, it speaks to me very, very nicely. Like we have companies that build excavators, and they put a camera on the mast of the excavator, checking for when teeth have fallen off, so that the teeth of the excavator don't go into the grinder. And like, this is a very rough environment, so you can't really put other sensors to do that. And you know, as a kid, I used to watch these machines digging up dirt all day long. It was super fun. And now that we have software running on them, it's extra fun. Sorry, I went on a long tangent there, but
the tangents are great in this. I think I'm about to go off on my own. I find it hard to believe that teeth are falling off of these excavators. They're massive.
No, they're totally consumable things. Actually, the lifetime of an excavator is something like 10 years, but the lifetime of the teeth of the excavator is only on the order of like 12 hours, because it's such a rough environment. Yeah. They have to replace the teeth all the time. These teeth are what's taking the impact when the excavator hits the ground, and it's what's digging into the ground. And so they're consumables. And they're made of some very rough metal, some very hard metal, so that if they impact rocks and stuff, they're the one that wins out. But even then, sometimes they fall off. And then when they fall off, they're such hard metal that if they find their way into a grinder, they can destroy the grinder, cause millions of dollars of damage.
Oh, wow. That's amazing. Hey, I want to take a second to welcome in our third panelist, Amir Zamir. Amir, also a former guest of the podcast. And Amir, why don't you introduce yourself and share a little bit about what you're up to?
Sure, yeah. Can everybody hear me?
Yep.
Yes, all right. So I'm Amir, thanks for having me. I'm an assistant professor of computer science at Swiss Federal Institute of Technology in Lausanne, EPFL. And my main area of research is computer vision. I work on various aspects of computer vision, multitask learning, unsupervised or self-supervised or transfer learning. These are all like sister topics. And ultimately transferring the perceptual modules that we develop to embodied agents, such as robots, to enable them to act rather than just passively view the world. And ultimately the intent of vision and perception is to act, is not just to observe. So that transition is also not trivial. So Reza talked about like some industrial applications. If we think about it, it helps somewhat with some decision-making, but also ultimately if that decision-making, if the loop between vision and decision-making is very frequent, it's essentially like a closed loop system. And a robot, for instance, is an example of a closed loop system. You constantly receive a stream from the camera and you act on it, or autonomous driving also is, which I believe you'll hear from Sidha soon. This is another example of it. So yeah, so I basically work on these various aspects of it. Machine learning is our tool these days, so we frequently research and applied machine learning as well. And more specifically, again, like 3D and video understanding is also another area that my lab is active on. I think that's it.
Awesome, awesome. So, Sidha, you're fully in the applied world. Reza, are you doing research in your Stanford professorship, or are you primarily teaching?
I'm
Trying to lay out
still
the
doing research.
academic landscape here of our panel.
Yeah, I think I'm straddling research and industry. Yeah, still. So I'm still publishing. We just put out a paper with the med school in computer vision. I can talk about that later, but I don't want to take away from Sidha's spotlight here.
Yeah, absolutely. So Sidha, you're focused on autonomous vehicles. For those listening in who may not be aware, you also recently published a book. I would love for you to mention that as well. But maybe as a starting question for you, I think over the past years, we've heard a lot about autonomous vehicles and computer vision. What's new in that area, and what is what are the challenges that are, not that we've solved many of the challenges associated with it, but what's kind of at the frontier from a computer vision perspective and autonomous vehicles?
Yeah. So I think autonomous vehicles or learning how to drive in itself is a pretty big task. And it's not just computer vision, so it's not just image or video data, but it's often multimodal. So you have different kinds of sensors, and you may also have different viewpoints that you're getting from different sensors. So I think, just listing out the challenges, in no order of priority, we have, should we do sensor fusion? What is the right way to do sensor fusion? Early stage, late stage? Then for the resolution of the camera, what should be the resolution? And so every stage of the pipeline kind of has its own challenges because there's no set way already defined, like let's say if I have to build a reverse image search engine, right? There are so many things that already exist and so many best practices that already exist. And I think when it comes to self-driving or autonomous vehicles, nothing like that actually exists. So everybody whom I've interacted with kind of, are trying to assimilate knowledge as they go. And at the same time, I think it's coming together of not only the data, the compute, and the training or the learning mechanism, but also the fact that policyholders or people who have the power to decide the policy and make policies for the future are also really engaged in this entire communication and development strategy, because it's kind of a holistic approach that needs to really propel us into the future. And I think that's where some of the more major challenges are, getting them involved into the conversation and really having the conversation of how do we make the system more interpretable, right? What are the metrics of explainability in such a system? I think those are some of the major challenges. And even in computer vision as a field in itself, we haven't really defined, what does explainability or interpretability actually look like? And to this end, I think maybe last year or the year before, DARPA had actually released this XAI challenge. How do we make these systems interpretable and so on and so forth. So I think there's a lot of work happening in each of these individual spheres. And again, it will all come together in the pipeline, but it's going to take a lot of work and a lot of time to get there.
When you mentioned sensor fusion in the context of AV, are you talking about a variety of sensors like LiDAR and these other things? For a while, there's there's kind of a clash of approaches. Some folks were trying to do, 100% vision based. Others were trying to integrate sensors. The vision group said that that's too hard and it's never going to work. And the other group said that you need all the, we need everything we can get to solve this problem.
Yeah.
Is that debate raging on, or are we, starting to converge on, a practice that we think works?
I think that debate will always be on because there is no, set best practices or a perfect state of the art system that we have today. So until that happens, I think everybody will, kind of approach the problem in their own way and see what works best for them. And I think that's really useful also because if you look at it from a crowdsourcing perspective, right, you have all these different teams, all these different companies looking at different approaches, and they will figure out the pros and cons of each approach in the longer run. So I hope that it's, for the benefit of the greater good and really trying to see which is the approach that really lasts the longest.
Got it. So we've got a question in from Devin. Devin, would you like to ask your question? You did in the chat, but would you like to come on audio and share a bit about your situation and what you're working on?
Sure. Thanks. And thanks everyone for doing this. My background is product management, a little bit of software engineering, a little bit of electrical engineering, but on sort of the machine learning and such, mostly just reading and taking some courses. But I am trying to build tools for creative professionals mostly, and in particular photographers. And a lot of it is around trying to give the camera systems more spatial awareness of the scenes that the photographer is working in, and using that to create new user interfaces and ways of interacting with the camera, specifically for gimbal mounted cameras, which a lot of times you don't have physical control over. And so there's a utility in having some robotic control over that. And I know this is less about machine learning per se and more robotic sensing, but I'm curious whether you guys have any experience with this and suggestions on sort of state of the art and resource constrained kind of ways of doing this kind of thing. Thank you.
So Amir, you do quite a bit of work on the robotic side and integrating in computer vision and robotics. Are you working on the scene construction, 3D scene construction, and any thoughts on Devin's challenge?
Yeah, thanks for the question. It's actually very interesting. Ironically, I had a similar discussion with a friend of mine in Silicon Valley a few months ago that about something like that. I mean, I probably can't say where he works, but interestingly, the initial reaction to it, that there's exploratory discussion was, I mean, that's not part of an NDA, so I can say it is that the industry is not ready for that. So, but I'm happy that Devin asked that question. So now I think that the connection to the robotic side, first to make that clear, is really if you want the automatic control of the camera. Or whether you have a cameraman that still is in control of the camera, but you want to create an interface so the cameraman can make more complex and better informed decisions. So if you want the camera to be automated, basically having a control system in place that actually moves the camera around and so on. So yeah, that becomes, that definitely has the robotics aspect too. But I think initially, it would be my initial hunch that actually having a system that is well informed of the scene and then conveys that to the cameraman, so the human is the last step of decision making, is still pretty valuable. And that's the unsolved problem too. So that involves a lot of 3D as well. When it comes to 3D, it's always a question of how you want to do the sensing. It's in a way similar to the autonomous driving discussion, is that, okay, well, what kind of sensing, how much you want to invest in the sensing, how much you want to invest on the software side. The answer really depends on different contexts. If you're thinking about a sensory package that costs something in the order of hundreds of thousands, Nothing cheap, nothing consumer grade that you would basically sell to individuals. Then yeah, you can afford actually having pretty good precise sensors and then do sensory fusion. There's a lot of actually research in the past, like multi-view 3D is not like a new topic. It's actually probably one of the first topics within computer vision that actually started working. It has some theories in it and so on. But if you're thinking, well, I happen to be on the side that I believe that much of what they try to do with expensive sensors has to happen on the software side. Basically, sensors that we have, something like LiDAR, it's a great sensor. It's very expensive though. And the only reason we need something like that is that we cannot solve the same problems that are solvable given like a feed of RGB images only. Using like machine learning and software engineering. We have got there. I mean, there's a lot of progress, but let's say till 5 or 6 years ago, like something like LiDAR would be the only way to solve them. Now we actually have even single image 3D reconstruction, something like single image to depth. If you think about it, that thing was not actually a thing till a few years ago. I'm a strong believer of sensory fusion, but I don't personally believe in expensive, like offloading everything to the sensor side. There are, I'm not sure what's the right structure for sharing like pointers, but there are like some software packages that you could use, like Colab and so on, and Colmap, sorry. But I wouldn't also say that this is something that is a matter of like cloning a GitHub repository and running. You probably want someone with a level of some understanding, some good understanding of these things. And it also involves like some struggling. It's not something that would work at the level of off the shelf. But looking at the specifics of the question, they also typed in chat, yeah, you were thinking about it the right way. I mean, probably want to mount multiple cameras, multiple sensors on system and have some sort of like shared 3D constructed. You can look at some of our prior works on this topic. We actually starting 2016, we worked a lot of like whole building 3D reconstruction using existing sensors and processing those, starting from a system that was called Building Parser. And then later we have a data set that was built off of it called Taskonomy. And then also there's something called Gibson Environment, which is like about 600 buildings fully reconstructed in 3D and so on. And since then we have been sort of, those data sets were created using sensors, not like super expensive sensors, but like pretty involved sensors. And since then we have been working on sort of creating the same outputs, but from RGB images only, and using machine learning. And so much of our work on like, single view multitask results, like last CVPR, we had a paper called Cross Task Consistency, is much about that, like basically allowing to produce the same outputs, but without having expensive sensors. So it might be a good start for you to look into the literature review of those papers that I mentioned. Then I'll be happy to also ask, specific questions if you have any. Thank you.
Yeah. I guess in some way to get some of those other references, was it Comath that you said?
It's called Colmap, COLMAP.
Oh,
it's more like some 3D, sufficiently well maintained. From ETH Zurich, or like a former student at ETH Zurich. I don't know exactly the specific affiliation right now. I could probably find the URL and give it to you, but this is just one example of something that is sufficiently well maintained, and you could use it more or less like off the shelf. But like I said, the whole problem is not something that I would say somebody without expertise in vision would be able to pull it together. So you might want to invest in having a team that knows that.
Yeah, totally understood. I wasn't expecting a totally off the shelf thing, but yeah, some references will be helpful. And
that's a very interesting problem. That's what I can say.
Appreciate your response. Thank you.
Amir, you mentioned something, you mentioned at the very beginning of your response that the market isn't there. Were you speaking were you reflecting on the conversation that you had and the opinion of your friend, or the state of the technology, or the state of the market from the buyer side?
The market and the buyer side. So, I mean, well, I'm going to quote like Henry Ford, that like he said that if I asked people what to build, like what they wanted, they would say a faster horse, but he built cars for them because, you know, it's not like people are good at like buying things what they want when they see it, but like you cannot rely on like consumers for imagining what products are ready and be, you know, delivered. So the conversation I kind of had the same feeling, is that, well, there's so much that we can do when you're aware of a scene that you're at, namely a cameraman. Let's say if you're a film production company, instead of relying on all these human skills, that it's incredible. It's like art, that you come in and you can actually design a camera trajectory that so well covers the scene with least camera motion, so you don't like get the viewer dizzy and so on. But you can think about it is that like the reason we needed to rely on humans to solve all those problems is that, well, like there was no way, at least so far, to have a good like digital twin of data space in a computer and do these kind of all this analysis. But now that the progress have been made in vision and machine learning community, you would think how they would be useful in that setting. And the answer is that the practices in those industries are still the same as prior to that age of like availability of these. That was the context of the conversation. But then, just like in everything in most like industries, is like the other side would have to be ready for adoption as well. And then, you know, there's some resistance. I don't think there's necessarily anything unhealthy. It's just a natural course of like adoption of new technology. But yeah, that was the context.
Yeah, I can briefly add that in some interviews and conversations we've had, we've heard a lot of that, and especially for video production, people aren't even using autofocus at this point. They're still manually focusing their lenses for the most part. And so, yeah, there's a long way to go for people to start taking on technologies, and it would probably have to start with some specific scenarios that are basically not doable by humans right now. So focusing on some of those first.
It strikes me that Sidha, the scenario that we're talking about here, understanding a scene in 3D and kind of mapping a path of a vehicle through that scene, is one that you're familiar with. Although your objective isn't necessarily to map the most creatively fulfilling path through the scene. But any thoughts on Devin's challenge?
Yeah, so first of all, the challenge is really interesting that Devin brought up. And incidentally, during this year's CVPR, there was actually some work presented that kind of utilized the creative aspect of, you know, scene reconstruction. And in particular, what the team did was, you know, assuming that they have a phone on the person, right, using the accelerometer data and camera data from the phone itself, you know, can you map out the path that the person will take? So if you've used Google Maps, you know, and you set up a destination there, so Google Maps usually says, you know, destination is to your left, destination is to your right, but oftentimes you actually have to, you know, find out where to the left, you know, which door to pick, and so on and so forth. So it's not exactly accurate. And so this team basically utilized accelerometer data to figure out, you know, does the person prefer walking on the right or the left of the pavement, and so on and so forth. And, you know, automatically figuring out the scene. So if they wanted to go to building A, the camera would be able to figure out which is building A in the scene that the camera is seeing right now, and figure out a trajectory and a path for the person. So this is a slightly different use case and application than autonomous vehicles, but I think it fits more with what Devin is originally referring to. And I think this work was presented at CVPR, so you can see the talk itself, the recorded version of the talk. And I think this is, you know, slightly different approach than what others have been taking, because again, it's low constraint, it's on edge devices, it can run on the phone. And again, the application is slightly different in terms of it's more catered towards what an autonomous or self-driving we know as the last mile delivery, but it's kind of human in the loop last mile delivery, if you were to call it that.
Cool. Reza, any thoughts or things that you'd add to what's been said thus far?
Well, so I guess I really look for what is ready to move from research and university labs and have them put into products. So I would ask, I guess, if there is, so full 3D scene reconstruction is a super interesting problem. I love working on it, but I feel like it's still more of a research problem, which I think what Amir was also mentioning is that it's a very interesting problem, but to take, say, 3 RGB cameras, put them around any room, like an arbitrary room that you don't know much about, and then have the images from that stitched together to give you how far every object is from each particular camera and where they are, and do that really to like a reasonable granularity, reasonable resolution. That's still a research problem. However, when I'm looking at Devin's question, he's asking, he wants to, at the end of the day, control the gimbal mounted camera for focus and framing. So really you need 2 things. You need to know where the object is and how far away it is. And it seems like, Devin, to solve that problem, you're looking to do a full 3D construction of the scene, which seems like overkill. So in terms of sub-problems that are much more reliable right now, and that you probably don't need to wait for the research to settle. Already the framing, that's, you don't need at all. You just need to frame the object that is being tracked. You only need 2D object detection, which is super simple and is super well done right now in any deep learning framework, TensorFlow, PyTorch. So framing is actually a pretty simple problem. Like, you could tell your camera and the gimbal to focus on a person, a car, a more very general objects, actually probably millions of different objects. You could just tell it to focus the frame on that thing, and it will guide your gimbal very effectively without knowing much about the 3D environment. It just looks for because you know where your camera is, and you know what you need to do to center the object in the view of your camera, if you know where in your camera's frame the object is. So for framing, you're actually okay. Like, you don't need much research. You'll be able to figure that out yourself. For focus, you'll need to know how far the object is from your camera. And for that, there are actually now some decent depth estimation algorithms that work off of RGB imagery as well. So if you look up some simple depth estimation papers, the research is a little less well-baked, but it's still much easier as a problem than full 3D scene reconstruction. So I feel like you might be looking for a more powerful hammer than you need, and the more powerful hammer than you need is still living in universities. And to solve the 2 variable control problem that you have, which is focus and framing, you'll be able to just do 2 problems. One is object detection, and the other is depth estimation, and you'll be good. Yeah, you might even be able to use a depth camera, like a RealSense or something, and that would be pretty cheap. Like a depth sensor, like a RealSense is pretty cheap these days, and so you don't even need LiDAR. Yeah, you could solve this problem if you just use a lighter hammer, basically.
The framing part of the problem, or in thinking about the framing aspect of the problem, you've got the detection of the objects, and then you've also got the, potentially what is the best framing of those objects and the kind of artistic perspective. And tools like Photoshop and others are implementing kind of ways to predict optimal framing. Of course, maybe you can take the recent Twitter cropping photos fiasco as an indication of how difficult that remains. And we're not even talking about video. But any thoughts on that artistic part and how you might attack that, or if that's something that you've seen or how you've seen it attacked, Reza?
So I was being much more simplistic than trying to be artistic here. I was just trying to solve the problem of framing the object in the center of the image, right? So I was being very simplistic here. With regard to creativity and making it artistic, certainly you could focus it at any part of the, I mean, at that point, so you could say, well, look, I always want the image to be in, I always want the person, for example, to be in the top left of my frame, and then and then follow them around in that way. That's kind of the simple things that I can think of. That would be the artistic. That would give some artistic control to the professional, and then let them decide other focuses. Yeah. So I with regard to like learning automatically what looks artistic, and then having an algorithm deal with that, I feel like that's actually doable too, with a big grain of salt where you have to tell the creative producer, this may be a racist, sexist thing, or it may be weirdly, it might just not work, but it's worth having as a tool, I feel, in the product that Devin is building. Like having a situation where the artist gives the algorithm maybe like 100 different examples of this is what I think is artistic, and then see what the algorithm learns. Probably it'll learn something reasonable, like typically it's good to have it somewhere in the center, and some other variations that the artist has decided are interesting, and then have it build off of that. That I think is also in the realm of possible right now. You don't need a research team. You don't need probably like to hire any students from some fancy university. You could probably just pull it off by rolling up TensorFlow or PyTorch. Yeah, but you have to, caveats that it could be very damaging if you're not responsible about it.
Yeah, briefly, that's a really interesting part of the problem. And the way that I've been thinking about it is there's this kind of continuum between automation and control, and sort of how much you're willing to let the system do for the person, which maybe is more at the more consumer end of the spectrum, versus like a professional photographer who would want to retain a lot more control over the details and specifics. And yeah, they're all relevant. I appreciate the feedback on sort of solving the simpler problem using the less big hammer. One of the reasons I've been thinking about full scene construction is thinking about remote control, where the operator isn't necessarily in the same location as the camera that they're controlling. But that said, I think that, there, like you said, there are certainly smaller subsets of the problem. And in fact, there are already products out there that will do like tracking of objects in frame and stuff. So yeah, you're right. That's a pretty easy, comparably part of the problem.
Yeah, if you can get away with the simpler solution, that's great. Yeah, can you explain a little more about why you wanted this full 3D construction? So you said you wanted control. So is this a drone that is flying around, or what's
a concrete use case is, for example, in event spaces, sometimes you'll set up pan, zoom, tilt cameras at different locations, and you have an operator somewhere, typically at like a mixing board, who has joysticks and is controlling all those. But the idea would be that maybe the photographer wants to roam through the space and sort of control it from a remote location. So that would be a typical scenario. That's one of the directions that I've been thinking about.
I see. Got it. Yeah. Yeah, in that situation, yeah, you might need something fancier. And like, I think at that point you should start listening to what Amir said. Yeah.
I also wanted to add one more point that I think I agree with Reza, that like you don't want to probably to be too ambitious in terms of like getting rid of all the sensors and everything that you could possibly use. Like you might not want to go all the way to LiDAR or the most expensive 3D sensors that are out there, but like a depth sensor, like one of these structured light sensors, are pretty cheap. Many of them actually paired with like cameras or a stereo. If you have concerns about like a structured light, you don't want to have active IR. So there are sensors that would give you some level of 3D. the question is mostly comes down to whether the understanding that you want from the environment is going to be centered at the camera that you're controlling, or really you want to have an environment centric understanding. If you have multiple cameras, and even if all of them have depth, you want to have some sort of fusion to kind of centralize your understanding. But if it's like one camera, then you want to make a decision about like, yeah, the rough whereabout of it, whether it can move a little bit without like colliding with other objects, or like how to at least do the autofocus. Then I think like having a depth sensor integrated would help. I mean, there's some specifics there too. Of course, if it's outdoors, you cannot really use a structured light because if sun interferes with it. You would have to go with something at least like time of flight, but the range is limited then. Then if you're like, I don't know, trying to, the specifics at that point like matter really. Like if the objects are beyond a certain range, the range of 3D sensors are not really that great. And the interference indoors, outdoors, and so on, these like become important. But I think at that level, you want more detailed conversation, I guess.
Thank you. Sam, feel free to end this. I don't want to take up everyone else's time, but just very briefly, the concrete hardware setup that I'm looking at right now is one of those pan zoom tilt cameras with one of the Intel RealSense 3D depth sensing things on it. And then the handheld unit would be a phone with a regular just camera and IMU. And so that was kind of where I was coming from as far as the hardware setup, but yeah, it might be challenging to fuse.
Do you have those. Like indoors or outdoors, or is it like a specific your application or anywhere?
I think that I should be designing for all situations. So that's a good point about some of these sensors only working indoors. So yeah.
Like if you use a prime sensor structured light, if the range is like in order of like tens of meters, it's not like tens of feet. It's not like hundreds of feet. So if the object, the one that you're considering, is not really that close to the camera, then yeah. So range and interference and these things are something else to keep in mind when you want to use. But you do want to generally use sensors as much as you can, and bring in the software and machine learning side only to fill the gap that the sensors cannot solve for you. Otherwise, like Reza said, it'll be like too much of a research problem that you don't want to deal with, probably at the level of like, your product.
Awesome. Thank you all. Appreciate it.
And your research has done quite a bit with sensors. The Xbox, I'm blanking on the name of their kind of LiDAR-esque. The Kinect sensor. Yeah, thank you. Is something like that interesting in a scenario like this? They're relatively cheap. They're relatively portable.
Yeah, the prime sense is basically that. Is like counterpart that, and they Kinect. The first version used a structured light. The idea that the system was that there's an IR projector that projects some random pattern on the wall, and there's a camera that sees IR. We don't see it in our eyes, but there's actually those patterns in the wall. And then it actually uses a system very similar to stereo. Stereo classically has 2 RGB cameras and with some baseline, and it relies on basically establishing correspondences between 2D images to infer the scene. Like you can think of it as like a disparity, whether when 2 objects appear too much displaced in one, when the camera is, let's say, there's a baseline of say 5 inches, that means that the object was closer to the camera. When something is like far away, like sun and mountains and so on, they would appear in more or less in the same spatial location in 2 images, despite of the fact that they have a baseline. Establishing these correspondences is too hard of a problem. It sounds ridiculous, sounds like very stupid, but when you have 2 images side by side, it's not always easy to establish correspondences, point correspondences between them, especially if it's texture free. Like if you're in front of a white wall, you don't really can say this pixel is the same as that pixel. We humans solve that problem by incorporating context. We look at the surrounding of the image and then, interpolate in between. But there was, believe it or not, there was actually no good, still there's no like completely concrete established way of solving that problem. And then came Kinect, which basically solves that problem by projecting that random pattern. So it replaces one of the cameras with these IR projector. So because this pattern is coded, it's easier to actually establish correspondences. But because of the interference, when you have IR, when you have active sensors, then there is like any amount of sunlight would completely dominate it. Then in the following version of like Kinect, they went to with another technology, was like called time of flight. So there is a wide range of sensors available out there, and we should use them as much as we want. They are just in some level, they're unsatisfying from perspective of a person like me, that I really am into like having a really detailed 3D, as much as like what I really want out of 3D is that like right now we are carrying around like a 4K camera in our pockets, like or beyond 4K actually, as a matter of fact. It's our cell phones, and you can take a picture and record the world with that amount of like fidelity. Sometimes it's easier for me to take a picture and zoom in because I see it better than like looking at the scene myself. So if we can start like kind of capturing the world, like recording world with that level of fidelity in terms of 3D, that's very empowering. The unsatisfyingness of the sensors comes from that basically aspect, that they're up in low resolution, way lower resolution than the RGB cameras that we have, or many of them involved on some active sensors, which then they limit their applicability. Like I said, interference with sun, range, like if you have something that projects something and returns, you cannot really like project, I don't know, where I'm sitting at is like across the lake, I see France from here. It's not like you can send a beam and, receive all the way the distance. Of course, the range is limited, but you can see it in an RGB. So that is the level of like something that you want to fill the gap between what we have now and then the ultimate 3D. Otherwise, the 3D sensors that we have right now, they're not actually that expensive. They're pretty useful. I'm a fan of using it, but I would say I'm personally a fan of integration. Like use this 3D sensors, but there's some gap that won't fill, and then that's when you want to kind of bring machine learning to interplay, rather than just completely like scratching it and then say, hey, I'm going to just do full 3D from nothing but RGB.
Mm-hmm. What's your kind of general commentary on the trajectory of the sensor world relative to, the algorithmic world? Or the sensors, is innovation on the sensor side happening as fast, or the algorithm's gonna innovate so fast that, we're not gonna need the sensor innovation as much? What's the relative levels of innovation across those two worlds?
And I guess that's a question that Sidha will be very well posed to answer, because they are trying to use those sensors for the downstream task of driving. And then to just give my perspective very briefly, I do believe that, the innovation in both sides is happening for sure. The innovation on the software side is faster at this point, because software is usually actually, the cycle of software is faster than cycle of hardware in general. Plus, like software hasn't started actually that long ago. So we are in the low hanging fruit kind of space, whereas like hardware has been like matured for much longer. Both is happening. There's a lot of effort on trying to bring down the cost of 3D sensors. Like I said, my money is on integration. Neither one of the two is going to be able to kind of eliminate the other. But the best solutions, in my opinion, will come from the point where we can actually use them in conjunction and then just fill the gap that one cannot solve with the other. Like I said, think like these examples I mentioned is really fundamentally hard to solve the problem of range at the hardware level. Like think about like what's the range of RGB? Like how far can you see? Like you can see the sun, like you can see as far as it gets, but we cannot really like, oops, sorry. I will false positive with Siri. Somebody should solve that problem first. Yeah, you can see really far, and in a way it sounds trivial. Like if you can get the distance, if you can understand the 3D of a car when it's like 10 feet away from you, why can't you do it when it's like 1,000 feet away from you? In a way, it's the same problem, but because the hardware relies on actually some specifics, like sending a beam and receiving back. So those problems are harder to solve, and that's where I think like software can come in to fill that particular gap. That would be my perspective, but there's definitely innovation on both sides going on.
Sidha?
Yeah, I would agree with Amir. In fact, before NVIDIA, I was at a startup called Deep Vision, And at Deep Vision, we worked a lot on edge sensors and defining software, particularly for each sensor. And again, a lot of that depended on the task or the downstream task that had to be done. And at NVIDIA, the scale of research and the work has changed a lot. It has increased a lot. But I think the challenges are both, at both places. Again, sensors, the rate of development, the rate of producing sensors in terms of hardware is slightly more long-term when you compare that to software. And I think that in itself leads to a lot more innovation on the software side, just because you can run, so many experiments and so many tests. And at the same time, when we look from like an AI or a machine learning perspective, there are new schools of thoughts that are coming up. For example, do you want to run your algorithms on processed data from the sensors or the raw data from the sensors? And so the networks, so the neural networks that we develop accordingly, they change, and the amount of processing power required also changes considerably. So I think it's a slightly more involved process, in terms of thinking through the end-to-end or the pipelined approach, because if you work directly on the raw data from the sensors, your algorithms will look very different. The interpretability or the explainability aspect changes by a lot, but at the same time, it's kind of a more black box kind of approach. And on the other hand, we have processed data. And again, processing it takes much more compute. So you definitely need a higher powered GPU or compute available on the edge device itself. And then again, that adds a lot more level of explainability, as well as it goes for kind of like a multi-tier compute. But there are also certain cases of a central compute living in, a lot of cases of autonomous vehicles. So I think it's, everybody belongs to different schools of thought, and there isn't one prescribed method right now, which again, I think adds to a lot of the speed of innovation, which is really, the need. And I think it leads to a lot of creative solutions that we're seeing around, in all these upcoming startups that work on edge devices or improving sensor qualities. And so I think it keeps the competition going.
Cool. I want to invite Chris to come on and ask his questions about, he wants to do some brainstorming around a product that he's working on. Chris?
Hi, everyone. Thank you for taking my question. My name is Chris Maxwell, and what I'm building is called Office to Go. And basically, imagine a very small RV, which its purpose is to provide people with an office. So what I'm trying to do is also, in addition to what you would imagine in a self-contained office, add a lot of technology, because that's my background. And so my question is this: being in the field and having a strong knowledge of the capabilities and innovations, if you imagined a mobile office that you could take anywhere and work anywhere with, but also at your home, if you don't have a suitable environment for work, or maybe like not enough space or children running around, what CV innovations would you add or think would be just perfect for this idea? And mind you, I just took it 5 months on the road, boondocking out west in very, very harsh and far away places. And it was amazing. So it's really great for that, but it's really designed for at home, so that people who maybe only have 1 or 2 bedrooms can have a private office that's really designed for optimizing work and improving the work experience in this new virtual workforce that we now have. Thank you for your answers.
I have an idea here. So one of the most impressive things I saw in a conference room that was set up, probably took a lot of setting up, is exactly actually the automatic gimbaled camera that follows you around the room as you're talking. So right now I'm kind of like stuck to this seat, and I'd have to walk with my laptop around to get anywhere near that same effect. Given that you control the whole room, the whole RV, definitely put an auto gimbaled camera in there so that if there's walkability in the RV, or just you want to move to the left or right, the camera can follow you. I feel like that's, yeah, you're doing that right now, and your RV camera should be doing that for you.
Right.
That's actually I guess the previous question is related to that. Yeah. So CV is totally ready for that. You can totally focus and track using
automated gimbal camera for tracking.
Yeah. There exists conference room video cameras that do this already. They integrate with Zoom. So actually, you might even want to just invest in one of those. I'm not sure what brand they are, but they exist already. So be sure to have that in there. Yeah, that's my 2 cents for now. I'll continue thinking while the others also pitch in.
Thank you.
Chris, I've been a huge fan of your RV2Go. I've seen it on LinkedIn and all those videos that you've been posting, and I think it's like one of the best things out there.
Thank you, Sidha.
When you were asking the question, I actually reflected back on the NVIDIA GTC conference that was just a couple of weeks ago. And there was an announcement around this software known as Maxine. And what it really does is, you know, everybody's online these days. Internet bandwidth isn't available to everybody. And especially if you're on the go, you know, if you're in a remote place, you're in Yosemite, working from Yosemite or working from Sequoia National Park, again, that is probably not going to be one of the strong suits. Maxine, the software that NVIDIA has released, it really utilizes the resolution of images, as well as making sure that the audio quality is maintained. So, you know, you can have high resolution plus good audio quality irrespective of your internet bandwidth. And again, it's a really good, you know, kind of combination software that's been released, and it runs directly on your laptop. It's very compute friendly, so it doesn't take up a lot of your energy or battery power. And I think that's one of the biggest, I would say, revolutions that I believe can have a huge impact, especially now that everybody's working from home and everybody's, you know, out. So that might be something worth considering.
Yeah, no, I actually saw that, and I was very excited about that because bandwidth has been a massive issue for me in my travels. You know, gas stations are about 100 miles apart, and so communication is even worse. So thank you. I'm really interested in that.
Of course, yeah.
Mir, any thoughts?
Well, very interesting. What I like, since you asked the question, what I've been thinking about is like, okay, there is definitely a lot of wish lists that we have for our offices, especially for the era that, you know, we mostly are connected virtually. But I was thinking like, okay, out of those general subset, which one of them are more relevant to an office to go? There has to be, I mean, there's a lot of things that we can do in our, you know, offices to make them more friendly. Like just the fact that the conferences are not actually that effective right now is a testification that even if I'm at my office, like everything that I have, full desk, best internet connection, it just can't, it's not as effective. And it's not like it's not my observation, it's like a community-wide observation. Since after COVID, we had to do, you know, most of the conferences virtually. So there's a lot of updates. I'm just thinking, which one of those are more relevant to a like on the road type of office? Then bandwidth is definitely came up, and I think that's seems like something that is more specific to an on the road situation. Similarly, I think like audio video technology, it's going to get a bigger hit when you're on the go. Like if there's noise, you want to have like more noise canceling, like software oriented, probably noise canceling. There's some, actually NVIDIA has another our like neural network for doing that. And similarly for video technology, probably you want to do, besides like controlling bandwidth, but you want to do some correction. These are more like image processing rather than computer vision, but they're still like, I think, sister topics. So do you want to do things at a level of corrections that it allows you to carry less hardware or less bulky hardware around? Also compression, I think what Sidha mentioned in relationship to Maxine is probably covers that completely, but there was also some computer vision, like neural network based compressions that were like by a large margin outperforming the compression of like a standard video compression. Because they're more specific to visual data, like JPEG and so on. They're specific to anything that can come out as like a two-dimensional matrix that we view as an image. But there's some compressions that are more specific to visual data, that like real world visual data. So they can be a lot more efficient than just being a general like compression system. I'm not sure actually how easy it is to make them like native to an Office system, but I think Sidha, what she mentioned about like Maxine will probably cover that already.
On the hardware tip, I'm imagining this thing as being the largest mobile hardware on the planet, because I have solar power, I have plenty of power, storage, and because I'm a programmer. You know, I envision besides little microcontrollers, I can have a lot more. So
you've not seen any of these data center submarines or ships? Yeah, those are
bigger.
A little bigger.
Yeah.
Well, Chris, haven't you seen?
Go ahead. I'm sorry.
I was gonna say, haven't you seen some of your pictures from like the Red Rocks and whatnot? The idea that jumps out at me, not related at all to mobile office, but for folks that are interested in off-roading and 4x4s, you have this issue of like line selection through the rocks. You often have, you know, someone who's out spotting you and telling you whether you need to turn driver or passenger so that you can get the right line to, you know, climb some, rocky trail in Moab or something like that.
Yeah.
And that, it could be an interesting computer vision problem, somewhat akin to the last one we were discussing, where you've got this, you know, vehicle that's navigating this this rocky terrain, usually with no, you're not worried about kids running out or balls running in your road. So a little bit easier than the full AV.
Like optimizing the path, that would be.
Exactly.
Boy, I could have used that. I could have used it.
Yeah.
Especially trying to maneuver myself out of tricky situations.
With that big trailer.
I've jackknifed it and dented it pretty nice with my my rear bumpers. Plenty of time. Yeah. So I imagine it having cameras in all sides that are accessible via an iPad from the driver's seat, because it has its own Wi-Fi antenna and server inside of it, but that it reaches the front. So I really want to capitalize on that. And, you know, and as you can see from the pictures, there's no windows, and I did that on purpose. The final product will have windows, but those windows have barn doors as well, because heat radiation is an issue. And so when you're inside, you can't open the barn doors. I really want to be able to see what's going on outside. And so I'm imagining, you know, because the geek in me wants to develop it, you know, some computer vision applications to detect what is it, you know, human, cat, or whatever. You know.
Nice.
Well, thank you, folks. I really appreciate it. Thank you.
One last question for you. Do you have stabilization so that you could take a conference call while actively driving? I mean, not being the driver, it's two people. Someone's dealing with the driving and then someone else is in the back doing a conference call. Do you have all of the stabilization necessary and the filtering of the engine noise and traffic noise?
No, nothing like that at all.
Well, there you go. More, yeah, for sure. You could add a super stable camera in there so that you could have a helper driver and then have a conference call in the back.
Nice.
Reza, would you do that with oil dampeners, or would you do that with computer vision?
I would do it with a gimbaled camera that can that they can deal with that. So the accelerometer just tracks what forces it's experiencing and then immediately corrects for it. So you have all these fancy cameras that you can do skateboarding and all that with one
Right.
of those. So just mount one of those in there, ideally one that can also track, and you'll have that somewhat resolved. Given that you're a capable engineer, you could hook that up to the tracking and the focus as well, and yeah, basically go all out on the camera in there.
Yeah, one thing that while I was, speaking of cameras, when I was on the road, I did meet somebody who did work in AI boondocking over by Zion National Park in Utah, and he loved it. He loved it, and he said to me, he goes, you should consider LiDAR. And I didn't think about, well, how? And I still am not sure what he was thinking about, how that would be applicable to this. But any ideas on that?
In the office or
outside to survey what's around, or so again, I wasn't sure, and I wish I had asked him more deeply, but we got really deep into another kind of tangent in the conversation. So I've been meaning to look into LiDAR because I know very little about it, and how that might be used. And the scene was, we were boondocking on some government land, Bureau of Land Management, about 30 minutes outside of Zion National Park. And it was really difficult to get to the location. So, and that was how he was imagining it being used, but I'm not sure what he meant. And it might be along the lines of what you were thinking, Sam, but I'm not sure how LiDAR would be employed for that.
Sounds like it. I think, if you're navigating narrows, being able to tell you how close you are to the rock that's going to put a stripe on your trailer if you are too close to it.
Okay. Yeah. Okay.
I kind of didn't quite yeah, exactly. I was gonna say there's
I don't understand. We're having healthy debates whether LiDAR is needed for even self-driving cars. So for something as simple as just scratch avoidance is overkill.
Yeah.
I mean, there's the cars have the radar based technology, which is pretty cheap. You can buy it on Amazon. A bunch of radar sensors can stick to any bumper, and they transmit to your cell phone. Something in the order of less than $100. You can put those sensors around a big RV. They're distant, so they just kind of the same. It's exactly the same as the backup sensor. It just raise an alarm when you're too close to an object. It doesn't do anything too fancy. It doesn't give you anything 3D, but I didn't actually quite get the problem that you guys were trying to solve with LiDAR. But if it's about managing the distance and so on, yeah, I agree.
No, I think that this is the classic issue of, hey, we've got a hammer, let's go find a nail.
Yeah, exactly. I couldn't think of a reason for it either. So I was, I think I wish I'd asked him in the moment what he meant. But
cool.
Okay.
Let's take another question. We've got one. Thank you, Chris. We've got one that came in from Pranjal. Pranjal, would you like to come on and ask your question? Certainly not necessary. Pranjal is asking about deep fakes and what, if any of the folks on our panel have, spent some time looking at deep fake detection and what the kind of latest technology thinking research is there. Any takers?
Yeah, I can take a stab at that, the beginnings of. So we're actually still in a very happy spot when it comes to deepfake detection. It's surprisingly easy to train even this simple neural networks to detect deepfakes, as long as you have one or two examples of the deepfake and then variants thereof. So it's actually the case that even though a deepfake looks very real to the human eye, convolutional neural networks, regular CNNs, are actually very, very good at picking up all of the nuances that show up when a deepfake is generated. So you might look at a deep fake and think, oh, that looks so real, but a neural network will focus in on the edges. It will focus on, say, if it's a person, the smallest change in the color of the person's eyeball, and things like that we can detect deep fakes with super high accuracy rates, like much higher accuracies than even person detection and car detection, which are like really easy problems for us. 99% accuracy. Deep fakes, you can go to several nines of accuracy still today with, of course, deepfake technology is always improving, but if you take any paper that's been published for generating deepfakes in the past couple of years even, I bet you I could get you a detector for that will have 3 nines of accuracy in detecting deepfake generated by that algorithm. So I'm very happy about that right now. We're tracking this. We care about it. We're tracking this at Matroid to make sure that we don't fall behind. But it's thankfully easy right now to do it automatically. With humans, like, you can't tell. They're at a point where a human eye has trouble. Yeah.
Hi. Just to jump in, so I'd just like to ask Reza. So how are you tackling the problem of generalization? Because there are a lot of data sources and there are a lot of algorithms for generating those deepfakes as well. So, how do you tackle that problem?
Well, this is the kind of thing that, so certainly it's easy to get lots of natural images, right? Abundantly free on the internet and elsewhere. So in the class of natural images, there's plenty of examples. In the class of deep fakes, you can generate a lot of them yourself. You can look for as many algorithms as you can to try and stay ahead. But what we find is that the artifacts that our algorithms learn from, say, the 10 different deepfake generation mechanisms that we use to train on the deepfake side of the classifier, they tend to generalize in the same way that a neural network generalizes to look for objects and to look for the things that we are comfortable just sort of agreeing that the neural network just learned something and is generalizing. So it's in that same vein. Like you get filters at the beginning of the convolutional neural net that learn to look for patterns that are unnatural, basically, and those generalize, and they generalize even to some situations where we have a deepfake generation mechanism that we haven't seen before. It's going to be a constant fight, though. I'm sure as the technology improves, we'll have more and more difficulty telling. But it's the case that a neural network's learning mechanism, the CNN's learning filters, putting it through some regular convolutional ReLU Maxwell layers, will learn things that generalize. And I can't always tell you like why, but that's the good news. And then the bad news is that, I expect that to change. I expect deepfakes to get harder and harder.
Cool. Sidha, is this something that comes up in the AV space? There's, certainly in the context of, adversarial types of attacks, a lot of those have been conceptualized as attacks against autonomous vehicles, stickers on stop signs and the like. Do you think about this type of problem as well?
Yeah, I think this is a very important problem to consider. And I think a lot of inspiration that I personally derive is from the field of computer security. And, that's a field that has existed for so many years. And today we have, well-defined signatures that tell us, okay, is this a man in the middle attack or is this something else? And once we know the type of problem or issue, we can, retroactively fix it. But at the same time, because this field has existed for so long, there are also ways to preemptively and proactively make sure that there are no incoming problems. And, you can intercept as soon as something anomalous or something out of the ordinary starts to happen. And And I think in terms of deep fakes, or more from a AI ML perspective, there is still a lot of work that needs to be done in order to make sure that we are preemptive or proactive about these issues. And again, the impact, I think, is a lot more on, mass media or general media and how people see it. Of course, using adversarial networks to train a more robust model, right? Be it stop sign detections, the traffic light detection, and so on. Again, that is always great, and it's always, helping to make the model more robust. But again, there's still a lot of work that needs to be done in order to make sure that we can clearly identify deepfakes versus original images. And I think to this end, there has been some work in terms of adding a separate signature to deepfakes. I recently read a paper about that. But a lot of this work is kind of retroactive. You already know what the deepfake is, and then you're trying to, improve the situation. But again, at the same time, I think there is a need to sort of proactively and preemptively figure out these things and try to address them as soon as possible. I hope that helped.
Great. Any follow up on that, Pranjal?
Yeah, definitely. Yeah, I agree with Sidha. And yeah, it's an interesting point that it's kind of an arms race, right? So people are working on detection, and then the other parties are doing the work on generation using those detection algorithms, and they are trying to outdo those detection algorithms. So it's always a cat and mouse chase going on, and the problem is that the people who are generating those deepfakes don't always reveal their algorithms. So as researchers, we are trying to get better deepfakes, but that's always a problem. So a person who has to work on detecting deepfakes has to work on generating deepfakes as well. So kind of a preemptive measure to see how others can actually make those deepfakes. So that's an interesting problem. And yeah, it was something that even I have worked on as part of my bachelor's thesis. So we were trying to generate deepfakes, and then we were trying to detect them. So what we noticed was that the deepfake data sets, they are not very similar. So basically, what our observation was that if you take one data set and if you train the state of the art neural network for deepfake detection on one data set, and then if you test it on the other data set, which some other university has made, so we would get even less than 50% accuracy. So that's the kind of problem I was talking about when it comes to generalization, because the thing is that the compression is entirely different, the resolution is different, then the pre-processing that is done, that is kind of different. So it's an interesting problem. Like if you take one data set, then you may kind of train your detector to, as Reza said, that we can get up to 3 nines of accuracy. But if you're taking into account that there are multiple kinds of generation algorithms, then it's an interesting problem that people are kind of still tackling it.
Got it. Thanks, Pranjal, for your question.
Yep.
I want to take a question from BipLab, which comes via YouTube. This one is in the chat. And there's a fair amount of detail here. So if you can take a look at that. The question is, the top performing ImageNet models greater than 88 top one, say EfficientNet using JFT as semi-supervised data, doesn't work well on MNIST digits. So are there any ideas on scalable open set recognition? And then BipLab adds some context, tried a few methods like OpenMax and variational reconstruction methods to detect outliers, but they mostly change position in PR curve. Anyone want to take a stab at that?
This is surprising that EfficientNet doesn't work on MNIST. I would question that. Yeah,
I think what he means is that is like pre-trained model that is trained on ImageNet is not going to do digit classification for you.
Well, yeah, that makes sense.
Which is expected.
Is that? Do you think that's his question? I can't tell. If you think that's his question, then we can take that.
It's hard for me to. I'm not very clear on the question either, and we'll welcome further elaboration via YouTube, or you can jump over and join us on Zoom if you'd like to.
I was judging by the fact that he talked about like open set recognition, because if you're trying to go from one set to another set, open set or open world recognition, I think that was the indicator to me.
Yeah, that's probably fair. No, I think you're yeah. In the meantime, please, Biblap, come on Zoom if you want. But I think that's a fair take on the question. In which case, yeah. So asking a neural network to generalize to domains that it hasn't seen this has been their bane of existence for a long time. Like it's been around as a problem since like we decided that neural networks weren't worth the effort because they could never learn, like a simple neuron might not be able to learn the XOR function. Like we said, okay, because of that, let's sort of give up on neural networks altogether. I mean, the reality is learning is a combination of memorization and generalization, and neural networks are just such that they are a little bit heavier on the memorization part, and so they need some examples of what it is you're asking them to do to build off of in order to generalize. And when you're looking at MNIST digits, they're just so different from ImageNet that there's nothing to recall and then generalize off of. And so, yeah, it feels kind of unfair as such a dramatically different domain. Yeah, I feel like we need much more machinery in order to have a model that's been trained only on, say, ImageNet type data, and then have that immediately transfer to MNIST. It would need so much more machinery that almost seems like it's like an AI complete problem. So like we're better off working on these other surrogate tasks that can get us more tangible progress than trying to go off of the training distribution by such a dramatic amount. But I'm willing. That's sort of like saying, well, look, it's a hard problem, and it's sufficiently hard that we're better off working on easier surrogate problems. But I'm willing to be told, look, no, we're actually close enough that we could work on this hard problem. Yeah, it's Amir, what do you think here? I think you're squarely in the research world. So do you feel like this is like we should start a new challenge to do this, or do you feel that it's like a little bit too much to ask of our current models?
It's definitely one of the hardest questions that it can try to address with existing machine learning machinery that we have today. So let me actually break it up a little bit. So, well, it's kind of like very sci-fi to, try to train an ImageNet and all of a sudden give it MNIST, and all of a sudden this thing recognizes that, oh, not only these are different domains, I'm going to introduce 10 more categories that my whole world till 1 second ago was like 1,000-way classification. Now I'm going to turn it into a 1,010-way classification, do it all its own. So one thing I think one thing closer to practice to think about is that just outlier detection. People call it sometimes OOD detection, out of distribution. So if you train on one data set and you give it a test time, you give test images from the same distribution, from the same data set. But let's say if you surprise it with an image from a completely different distribution, we need models that at least they can have that uncertainty measure built into them that say, hey, like this is something that I'm not going to answer, let alone like just reformatting and restructuring on the fly and say, hey, now I'm going to do digit classification. So that is an active line of research. It is not a solved problem. I can point you to some literature for, I'm speaking to the person who asked the question, I got the name.
BipLab.
BipLab, yeah. So I can, the literature to look into is that all those papers, mostly in the machine learning side, not at the vision side, that discussed like the overconfidence of neural networks for their mistakes, and generally confidence metrics. Like confidence metrics is what you want, is that like, you know, ideally you want you to be confident about your correct decisions when you're in distribution. And for anything that is out of distribution, you want the confidence to be low. In my lab, we worked on some energy-based models for solving that. Like in last CVPR, there's something called cross-task consistency that has some built-in energy for doing it. And again, there's some literature review of that paper they can look at for some pointers. That's probably the fastest way that I can convey that to you. But I guess we're all in agreement. It's a really hard problem. That's one of the hardest things that you can do. The things that are being addressed in the research community right now, like I said, is at the level of, let's say, at least let's have some good uncertainty metric built in our models that are very useful. I mean, nothing is going to work in the real world, like trust me, without having an uncertainty metric built into some prediction model. And then also related to that, I think a little bit further, but all the research on like unsupervised or self-supervised representation learning is something that is basically trying to do that, is that I'm going to learn a representation that is not so much tied to a specific task. And then ImageNet or MIT Places classification or anything, those are become more just only validation, not a training setup for me. And then if I can solve ImageNet without using it actually at the time that I was developing the representation, chances are I would be able to would be more ready to solve like unseen problems too. So in that sense, still that's like, it's not like we have a method that can learn like a self-supervised representation without anything or like, you know, solve all the problems. But there has been progress in the field in that front, like contrastive methods right now seem to be the one that are like leading the wave. I'm a little skeptical about generally reading too much into the success, because we have to remember that what we call the way we evaluate self-supervised representations these days is just to still evaluate an ImageNet. So we are right now solving ImageNet. We are not really solving like vision. So it would be, yeah, it would be believable that at some point to have like really good self-supervised representations that solve ImageNet without using ImageNet data. But one thing that is actually very absent in from evaluation these days is that, well, if it works for ImageNet, does it work for other tasks too or not? And the answer is usually no. But that's not the problem. The problem is it's not even part of the standard evaluation setup. So I'm a little bit more skeptical to declare victory on that front. But it is related to the open set recognition in that sense, that if you have a self-supervised representation that is not tied to a specific problem, indirectly you would have solved the open set recognition to some extent too.
And Sidha, do you have anything up your sleeve that goes against what our previous panelists have responded? Have you solved this at NVIDIA?
I think it's an ongoing problem, but I again wanted to highlight what Amir said, because I think the question actually mentioned semi-supervised data. So I was thinking along the lines of self-supervision and contrastive learning, as Amir mentioned. And, you know, they've shown in a lot of experiments, I think coming from Facebook's AI labs, that with different pretext tasks, you can have, you know, going from ImageNet to MNIST, and there's a lot of variety in the experiments plus the downstream tasks that can happen. I think there are also some examples of text and language. So I think there is definitely something going on in there, but again, there are a lot of unknowns. The field is relatively new, or at least some of the advancements are relatively new, and a lot of skepticism is necessary in this area for us to ask the right questions and make sure that we are developing along the right lines. And I also wanted to clarify, like, if the aim is to work on MNIST dataset, then maybe something like EfficientNet would be, you know, too big a hammer for a smaller nail. And, you know, you can easily start with something that's much, much more smaller. And if you're going along the efficiency route, you know, there are experiments with using smaller size convolutions, depending on the hardware at hand to make sure that your network is as efficient as possible. And to this end, there's also some research along data drift and model drift. So, when you deploy a model, the target distribution of that model will eventually change because of changes in data. And so there has to be like a continuous CI/CD pipeline in place that actually gets, let's say, low confidence data and trains the model on that low confidence data. And so that's also, coming towards more of a deployment scenario or production scenario, which is pretty common in, a lot of the companies that do deployment of machine learning or AI models.
Awesome. Thank you, Sidha. Well, that's all we've got time for today. I'd like to thank our panel, Sidha, Amr, and Reza. Thanks so much for participating in this. Thank you, everyone out in the audience, for your great questions and discussion. These office hours has been an interesting experiment for us as part of TWiML Fest, and we've had a ton of fun with them. So they will likely continue at some point. So if you've got ideas for future office hours, we've done so far this one on computer vision. We did a one on reinforcement learning and one on NLP. Sidha, you were just talking about CI/CD and ML ops. We may do one on that topic sometime soon, but we're open to ideas there. But thanks everyone for making this a great session.
Thanks for organizing this, Sam.
Thank you. It was fun.
Yeah, thanks for having us.
All right. Bye-bye.
Thanks everyone. Bye-bye.
Bye.